Now we'll discuss in detail about heat engines. When we talk about a heat engine, we can write it is a device which partly converts or partly transforms heat into mechanical work is called a heat engine. And the basic diagram or the block diagram of a heat engine can be drawn like this. If we consider this as a heat engine system, it takes heat from an external system which is called input heat, where we are supplying heat to the heat engine, and it does some amount of work which is called output work W. This is the output of heat engine. It accepts heat from an input source and does an external work W on the surrounding, which is called output. And in the process, heat engine always rejects some amount of heat, which can be written as Q2. This is called rejection. As we have studied in second law of thermodynamics that 100% transformation of heat to work is not possible. That means work will always be a fraction of a supplied input heat, and the remaining amount of heat will always be rejected by the heat engine before completing the cycle. So in this situation here we can state by energy conservation, here Q1 is the supplied heat and a part of it is transformed into work and the remaining amount of heat is rejected as Q2. So the output work which is done by the heat engine in its cycle can be written as Q1 minus Q2. Always remember it. And when we talk about this heat engine, it is basically a gaseous system in which the gases or the fuel which is used for acception of this heat and rejection of heat and doing work. This substance we call working substance. The working substance is actually fuel of the heat engine, in which we can state it starts from an initial state where it accepts heat Q1 from the input source, does some work and comes back to the initial state and rejects an amount of heat Q2. We'll discuss about the heat engine in detail here. Right now we have discussed only about the basic fundamental of a heat engine, how it acts and what are the components of energies which are involved in the heat engine. One is the input heat, other is the rejected heat, and one is the work done which is done by the heat engine. For a heat engine we can write that a simple heat engine is a thermodynamic device which undergoes a cyclic process of a working substance, which we generally call the fuel of this heat engine. And all of us know that in a cyclic process, whatever amount of heat is supplied is net heat is supplied as used in doing work. So if we talk about a clockwise cycle, always remember if heat is being transformed to work, you can always remember the cycle must be clockwise. Say from state 1, a gas is taken to state 2, and finally by another path it comes back to state 1. Say its expansion path is 1 and its compression path is 2. And say the volumes involved are V1 and V2. So in this situation, when the gas is being expanded, we can say that an amount of heat Q1 is supplied to the system, and when it is being compressed, a heat Q2 is rejected by the system. Now in this situation, the total work done by the gas will be the area enclosed by the PV curve, and this total work which is being done, W net we can call, which is being done by the system must be equals to Q1 minus Q2. As in this situation, always when the cycle is completed, we can write delta U is equals to 0, because here the total amount of heat which is being supplied, a part is transformed to work, and when it is being compressed, a part is rejected and some work is done on the gas. So net work can be written as by energy conservation, it is Q1 minus Q2, as the final state is initial. So total change in internal energy is 0. So here we can write the total amount of heat supplied as Q1, which we call input. This heat is rejected, which is a waste, which is not being used again by the heat engine. And net work done by the system can be written as its output. So using this input and output, we can define thermal efficiency of heat engine, which is denoted by the symbol eta, which can be written as obviously output by input. So in this situation, this will be W upon Q1, where W is the total work done by the heat engine and Q1 is the net heat supplied. So here we can write this eta as W can be written as Q1 minus Q2 upon Q1, which is 1 minus Q2 by Q1. And be careful, as Q1 is positive which is supplied, Q2 is negative which is rejected. So here we are taking magnitudes of the amount of heat supplied. So efficiency is defined always as a positive parameter, because always some amount of heat is transformed to work. And by looking at this expression, you can see that always some heat will be rejected, so this efficiency can never be 1. In percentage, if you wish to calculate the efficiency, this can be multiplied by 100. So this will give us efficiency in percentage. So always remember another form of second law of thermodynamics, that second law of thermodynamics can also be stated that no heat engine can have 100% efficiency. This because 100% amount of heat can never be converted into work. So we can simply define a second law of thermodynamics as no heat engine can have 100% efficiency. This is another form which we can use. In this slide, we are going to discuss the block diagram and components of a heat engine. As we already discussed about the idea of a heat engine, say this is the device in which the working substance is being consumed. It is written as a heat engine or an engine. It takes heat to initiate the process from a region which we call as source, which is at a high temperature zone. Say it is at temperature T1. And when it does work to the surrounding, say it does a work W, some amount of heat is rejected to the surrounding or a zone which is at lower temperature, which is termed as sink. Say sink is at temperature T2. So always remember T1 is always more than T2. In case of the working of a heat engine, it always takes heat from a high temperature zone and rejects heat to a lower temperature zone, and in between, by the working substance, when it undergoes a cyclic process, some work is done. And obviously, as we already discussed, by energy conservation, we can write Q1 is equals to W plus Q2. So these are the three components of a heat engine. One is the engine, in which working substance is taken and a cycle is processed, and there is a zone which is named as source from where heat is supplied to the engine. And in the process, cyclic process, when the working substance undergoes a cycle, some amount of heat is rejected to a zone which is termed as sink. Generally, in case of most of different kind of engine. Sink is the atmosphere or surrounding of the engine, and the source is basically the carburetor in which the consumption of fuel is there, in which fuel is burnt and heat is produced at a specific temperature T1 from where heat is supplied, or it can also be taken as a zone connected to fuel tank of a heat engine. So be careful about the working as well as the components of a heat engine.